In this video, we will look at edge weights and how to create a graph. So first of all, what a weight is, kind of depends, but it is assigning something to the edge, a value to the edge of a graph. Okay, so for example, if I had a graph A connected to B, very, very simple graph, right? I could give a number to the edge. I could say, well, A to B is 5. Now, if it was a map, let's say two cities connected, maybe that represents 5 miles. Might represent 5 kilometers. It also might represent 5 minutes. Maybe it takes 5 minutes to travel from A to B. And there could be a variety of things that 5 could represent. But in general, a weight is something, a value that we assign to the edge. All right, let's take a look at an example. So what I did is I went to Google Maps and connected some of the cities or communities, I should say, right around the Lemoore area. So I have a map here of how to get from Riverdale to Layton. Okay, that's 9.7 miles. Then I made another map, how to get from Riverdale to Lemoore. By the way, these are walking paths. So there's a map of Riverdale to Lemoore, and that was 12.9 miles. Here's Riverdale to Armona, 16.3 miles. Lemoore to Armona, Layton to Armona, Layton to Lemoore. Now, let me just show you in general what I was doing. Okay, so I was thinking about communities in the area of the college, and those 4 communities I thought about are Riverdale. I'll put a vertex there. I'll put a big R for Riverdale, right? Layton. Now I'm going to put a T for Layton, which you'll see why in a second. I did an L for Lemoore, right? And I'm going to do an A for Armona. Okay, so I had 2 L's, so I had to figure out something. So what I was really interested in is how are all the different ways that we can connect those? Well, you saw from the maps that they were following roads and so on, but in general, I want to connect all of the communities with one another. I want to connect T to A, right? I want to connect A to L. I want to connect R to L, and I want to connect R to T. Oops, R to T. But I also want to connect L to T, and I want to connect A to R. That is all possible connections on the map. Now, what I've drawn with these straight lines are not realistic or maps of the routes, right? You can't just drive through an open field, but it's an abstraction of what's really going on. Like, for example, this is how you actually might get from Layton to Lemoore if you were walking on the roads, right? Kind of a jagged path. And I've abstracted that by just drawing this diagonal line from here. Now, what we can do further is we can say, like, in general, what are the connections? Well, really, the connections are that we have 4 vertices, we have 4 communities, right? And I'm just going to label them with letters. So I have R, Riverdale, T, Layton, L, Lemoore, and A, Armona. And then we have 6 edges. And so I could actually draw this any way I want. I'll just draw it as a sort of a box. Now, what I've done now is I've really abstracted this drawing. It looks nothing like the original Google Maps, other than I have places that are connected. So what I can do to make this map even a little bit better is assign edge weights, as I mentioned earlier. And I'll give those realistic numbers by just going to these numbers I got here from Google Maps. Riverdale to Layton, 9.7, Riverdale to Lemoore, 12.9, and so on. So I might drag some of these over here so I can kind of see them all at once. I'm going to drag these. These are just the numbers I got right off of Google. And then I'll assign those to my map that I've made up. So I'm sort of making an abstract map. So kind of taking them one by one. Let's see. Lemoore to Armona is 4.9 miles. So this edge would have 4.9. Riverdale to Lemoore is 12.9. This edge is 12.9. Riverdale to Layton is 9.7. That's this direction right here. Layton to Lemoore is 14. That's through the middle here. All right. Riverdale to Armona is 16.3. That's this other diagonal. And lastly, Layton to Armona is 9.2 miles. Now, with this abstract graph, right, we kind of have an abstract map of what's going on. We can decide and talk about routes and use the weights to think about how long the routes would be and the distances and so on. So this is a great way to think about a complex map and make it a little bit easier to work with. So that's often why we make a map. Let me look at 2 other examples. All right. We mentioned that graph theory kind of got started by this idea of Euler looking at an island with bridges and a map. So here's a hypothetical problem from our text. Suppose the town has 7 bridges as pictured below. Create a graph that could be used to determine if there's a path that crosses all bridges once. Now, you could just play around with the picture here, but creating a graph, you'll see later in the course, is an easier way to think about it. So what we first have to decide is, okay, well, what are our edges and what would be the vertices? So the edges, in this case, will be the bridges, right? The bridges kind of connect. And the vertices will be the land masses, whatever they are. All right. So we're going to give those land masses some names. I'll just call this top piece landmass N for north. I'll call the bottom one south. And then I'll go east. And I'll give that one E and this one west. And then I have an island in the middle. I'll just call it I for island. So we can abstract this with a graph by saying, okay, each one of those pieces of land is a vertice. I might arrange them like this. W, I, and E in the middle, something like this. All right. And then I have N on top and S on bottom. Very abstract. Now I connect those with the edges. And what you want to do is just kind of copy the bridges. Notice that the bridges, there's two ways to get off of W. You can go either north or south. So I can go from W to the north. I can go from W to the south. And likewise, there's two ways to get from E to the north and the south, right? Connect E to the north and to the south. And then finally, I'm going to go and look at how I is connected. I is connected first to the north. All right, so that's going to go directly to the north. Here's the part that's a little bit interesting and tricky, is that I is actually connected to the South Island two different ways. So that means I'll just draw an edge from I to S and then another edge from I to S. And then there's two ways to get that done. Now, I'm not going to finish this problem, but once you have this graph, you can use this to determine if there's a path that crosses all the bridges once. We'll see that later in the course. All right, let's look at one more example. This is an example of a traveling problem. Let's say that this is a table that shows the values for flying from any one of these communities to another community. So these would be airline ticket costs. All right. So you can see Seattle connects to Honolulu, Seattle connects to London, and so on. So what you might do is say, like, well, how many cities do I have? Well, I have Seattle, right? That's one, Honolulu, London, Moscow. And then lastly, we have Cairo off to the right-hand side, kind of sneaky, hiding over there a little bit. All right. So once I realize there's 5 communities, what I might do, or 5 cities, I might just draw 5 vertices kind of around in a circle. Now, that's not at all realistic to the world map, but for the purposes of graph theory, it'll work just fine. Call one Seattle, call one Honolulu, call one London, call one Moscow, and then call one Cairo. All right. And it looks like each one of those is connected with another one. I'll show you how to do these kind of one at a time. Like Seattle connects to Honolulu, right? So I could draw an edge there. And since it costs $159, I'll give it an edge weight of 159. Seattle also connects to London. Well, yeah, so I draw an edge there, Seattle to London. That would be 370. Seattle connects to Moscow. That's $654. All right. So I'm just kind of drawing those in. And Seattle also connects to Cairo, $684. Now notice as I'm drawing this map that the length of the edge really doesn't correspond to the weight. So the weight really just tells you the cost here. Honolulu is connected to London. Maybe I'll use a different color. Honolulu is connected to London. That would be on the right-hand side. That has an edge weight of 830. All right, and you can see that as the more I draw into this, the harder it is to determine which weight is assigned to which edge. So you have to be very careful about that. Moscow to Honolulu is 854. So that would go from there to there, 854. And I'm not going to finish the rest of this with all of the numbers, but what you're going to find out in the end is that every city ends up connecting to every city. So I have a connection there. And lastly, we have a connection there. You'd have this connected graph where every city, and they would all have these individual assigned weights, and it would help you to be able to evaluate costs and traveling routes. And so this is the idea of how to create a graph from a given set of information.